So the next session will be handled by Dr. Rekha. So this is the last session of our FDP. So till 6:20, ma'am will be handling. After that, we will have the test. So any queries, you can WhatsApp me. So I'll give a brief introduction about the resource person. Dr. Rekha is currently serving as an associate professor in Division of Electronics and Communication Engineering at Nala Narasimha Reddy Education Society's Group of Institution, Hyderabad. She obtained her PhD in Design and Development of Substrate Integrated Waveguide Antennas. Her research interests include wireless sensor network, antenna design, particularly substrate integrated waveguide antennas, reconfigurable antennas, and MIMO antennas. She has published more than 30 research papers in reputed journals and conferences. She will be handling a session AI/ML driven prediction and optimization of antenna parameters. We welcome you, ma'am.
Thank you, Shainak ma'am, for your warm welcome. First of all, good evening, one and all, and I'm so delighted to be a part of this online art on FTP, and that too last session of the day. Uh, I thank the organizing coordinators for giving me such a wonderful opportunity to interact with you all. And I believe that from the session, you will be having some takeaway for your academics as well as research. Okay. So, without further delay, I would like to start into the session, and I would like to uh, give a introduction, otherwise a brief discussion on AI/ML driven prediction and optimization of antenna parameters. I believe by this time you would have come across many AI/ML algorithms. You would have got knowledge about it, and some must be inspired about these algorithms. Uh, but here I would like to connect this AI/ML algorithms with the antenna parameters. That will be helpful for people who are working in the communication side. Once again, I'm Dr. Rekha from Hyderabad. My list of contents goes like this. So it starts with introduction. What are the challenges in the conventional methods, and what is the necessity that we are moving towards this AI/ML algorithms, and what are the major algorithms which is being used right now in the antenna design, and general flow diagrams of few algorithms. And I would like to specifically talk about this genetic algorithms and particles from optimization. Although it was created decades before, but I believe that the if you have any detailed knowledge on any two to three algorithms, whatever algorithms coming in future, you can able to make it up. That will not be a difficult part. So you will feel like it is a piece of cake for you. So GA and PSOs are really interesting, and with the help of that, you can do a lot of wonders in the antenna design. And not with that algorithms, and I would like to show some examples, otherwise case studies, which involve this genetic algorithm. So, a little introduction. In if you see from 1950s to 1970s, the AI/ML has started its phase. It has started with its games, puzzles, and robotics and applications like pattern recognition, speech, medical diagnostics, and weather, and so on. And few decades before, it has touched the area of wireless communication, particularly antenna design as well. And what we are trying to do with that techniques in the antenna design is nothing but your optimization of antenna parameters. Because of the advancements in that computing powers and storage capabilities, and this algorithms plays a wonderful role in handling a large amount of data. So what we do, we will simulate, we use such simulation tools like HFSS, CST, and if you try to optimize, we have to work on it. You change the geometry, you change the antenna parameters, you change the slot size. We have to work on it, and we keep on working and working. At one point of time, we will lose our patience and we will be frustrated. So to avoid that, so what we do is we depend on, otherwise we seek the help of these algorithms to make our work easy. So what do we do here actually with the use of these techniques? What we do here is we predict the antenna characteristics such as your gain parameter, directivity, S parameters. We can predict the performance parameters. Otherwise, what we can do, we can predict the input parameters such as antenna size, the total size or the slot. If you have a slot, what should be the length, what should be the width. Okay, you can predict or work on with the physical dimensions of an antenna. So you can work on the physical dimensions. Otherwise, you can work on the performance characteristics of the antenna without putting much effort from human side. And the applications of this include wireless communication, satellite. You all know antennas are helpful in all these areas. And as I told you, challenges is, suppose if you want to get a particular gain, I want this much of gain, I want this much of bandwidth, radiation pattern. This should be my impedance matching. It is difficult for us to sit and optimize better. Then in that case, we will depend on a machine. What we do is we will train it. Okay, already we'll simulate a design, and we'll take information from the design, and we'll train the model such that the model will learn. Okay, for what input parameters, what is my output parameters. Otherwise, if this is the performance characteristics, what should be my physical dimension. The model, you are training a model such that whatever new values you give to the model, it will tell you or predict the input parameters, and otherwise the performance parameters. So this is one of the major challenges in the conventional methods. So to avoid that, we are seeking the help of the ML techniques. And that too, single antenna is okay. Suppose if you are going for multiple antenna, MIMO antenna, arrays, you are going for a lot of arrays, then our work becomes complex and complex. In that case, this is a extraordinary boon for us to depend on that. So what are the major algorithms which is used right now in the antenna design, if you ask me? Like neural networks are there, genetic algorithms, PSO, SVM, surrogate modeling and hybrid AI approaches, artificial B quality algorithms. All these algorithms, or most of the people have started to use it. They are not new, they are already in the picture. And if you take a detailed analysis of what are the algorithms, which is what is the percentage of share of algorithms which is right now being used, means if you say neural networks plays the major role here. 42 percentage of the work has been done with the neural networks. And the next one is genetic or evolutionary algorithms, which has 52 percentage of share, and SVM is 11 percentage, and surrogate modeling 10 percentage, and other plays a role of 5 percentage share in the antenna optimization methods. And otherwise, if you see it as a pie chart, these are the other algorithms. As I said, other algorithms. These are the other algorithms which are also playing a major role in the antenna optimization in the recent decades. And publications wise, right now, just working on the only antenna, only with the help of the tool, has been little saturated. So what people are from the publication side, what they're expecting, they're also expecting us to include the AI ML techniques into the antenna design, so that our work will become smarter than ever before. And if you would have seen recently, almost in the recent years, almost more than 150 publications, if you see, all the papers are implementing this AI ML optimization techniques. So this is a good area to be chosen. And if you see the potential and open research areas of AI ML in antenna design, there are different areas. Which one we have to choose? So in that case, you have geometry optimization. So what you do is you will find out what should be the size of my antenna. So So what should be the size of the my antenna, what should be the slot length, what should be my slot width. So all this we can do it in the AIML techniques. Otherwise we can do frequency tuning uses techniques like AN and DN and GARL, right? Suppose I want to tune it to particular frequency, manually I tried it many and many times, I put the slot, I use this, I use that, but it doesn't work. I do not know how to work. In that case you can go with the AIML techniques. Otherwise, if you are doing or working on a pattern, so if you are array of antennas, if you want to synthesize the pattern, like actually pattern synthesis is a process of what designing and adjusting the amplitude and the phase of the antenna element, so that what happens is the radiation pattern will meet the desired specifications. That is called as pattern. You are adjusting your pattern. So ML techniques is also helpful in the pattern synthesis and array optimization. What happens is in the arrays you have similar antennas placed in some particular fashion. What you can do is you can change the amplitude, phase, position, and geometry. So you can do everything. You can play around all these parameters and you get a desired array. For example, maximum gain in a particular direction, otherwise minimum side lobe levels, otherwise what you can have is a specific beam width or specific pair shape. Like some application they ask for the pencil beam shape. So all this can be you can done with the help of the array optimization. Then coming to EMC optimization means you have to make sure that your antenna is working in a particular environment, electromagnetic environment, and also our antenna should not cause any disturbance to any other nearby antennas, otherwise, or the electronic devices. Otherwise, what we can say is our design, our antenna should be immune to other external interferences. So EMC optimization can be done. And coming to non-linear optimization means you find the best solution to your problem. So even if there is a non-linear relationship between your output parameter, there is no linear relationship, it is fully non-linear. Means what you cannot predict, you cannot deterministically say that this is the relationship between your input and output. In that case you can very well go with that this ML techniques. GA will help you, PSO will help you, NN will help you. Other research areas like computational complexity, like if you are more worried about the time and the money, so in that case which one will give you better better computational easyability. So all these things you can do. Otherwise what we can do is we can work on with the convergence and stability. So convergence means to find the optimal solution, like a minimum of a function or a maximum of a function. Otherwise a global or local convergence, that is your convergence. Otherwise stability, how your algorithms has the ability to stay near the solution. So that is your stability. You can work on convergence, otherwise the stability. So these are the different research areas. Based on your interest you can choose your research area and choose a algorithms which are related to that, and you can start working on it if your field is wireless communication and NAND design. And the general flow diagram, okay, for anything, for any algorithms, any AIML algorithms, general flow diagram goes like this. First what you do is you have to design. You have to design whatever in any of the tool. You have to choose the design of the experiments. You have to choose it, you have to design it, and from that what you do is you have to get a data from it. Like what you do is you run your design for a particular range of frequencies, and what we usually do is we use it to hard code the values. This is the patch length, this is the patch width. With hard code, you don't hard code, you have to give some variables. So and that in that tool only you can change the variables from this is the minimum value to maximum value. This is called optimetrics. Okay, so with the help of optimetrics you can get the range of data from the simulation software. You can take thousands of data, we can get it, not an issue. That data, what you do is that will be used as a training and that test data, and that you have to use it to build a machine learning model. So machine, now the you are training the machine model, so that it will adopt for what input, what is the output. It will learn from the whatever input you give. And what you do is, then you it will give the if you give any other inputs which is not in the simulation software, so that will work on it, and it will try to give your predict your inputs, otherwise output. Then you validate it. If your validation is correct, you get the result. Suppose if it doesn't work, means your whatever input data which you have given is not enough. So that what you do, you can increase the number of data, and you can give it again, you can train it and test it, and you can just one more iteration. Suppose the data is insufficient, and this is how you are flow diagram using any machine learning AI.
Ma'am, excuse me, ma'am. Ma'am, there is some background noise.
Right now, ma'am.
Yes, ma'am.
Shailat, ma'am.
Ah, yes. Okay, ma'am. Okay. You can
Shall I continue?
ma'am. Yes, yes, ma'am. You can continue.
Okay. So as I have discussed antenna parameters, what antenna parameters to be predicted, otherwise optimized means it may be a gain of an antenna, or directivity of an antenna, or the bandwidth, or efficiency, radiation pattern, or even the polarization. Otherwise, impedance matching is always a trouble when you are designing antenna. That you can do. Return loss, and what is the size of the antenna, what is the material characteristics. So all these antenna parameters can be predicted or optimized using this AI or ML techniques. So let me start with, as I discussed, I'm starting with the genetic algorithm. So this is one of the important tool for search and optimization. So this has been done based on the Darwin's principle of nature selection. It is nothing but survival of the fittest. So it involves biological process of genetics and evaluation. So what it does is it randomly search for the best ones, and it will try to optimize it. So this is the this is from the genetic systems. So survival of the fittest, this is called survival of the fittest. So uh, I would like to go a little more detail into it, one with some example, as well as I will show you a MATLAB code how this genetic algorithm works. So I hope by this time you will all be very well have the knowledge about the optimization. It's nothing but finding the best one out of all feasible solutions. That is your optimization. So generally, what's the problem with the traditional method is, we'll try to optimize a function, but what we do is we end up with suppose we are going for a minimization problem, means we have to find out the global minimum position. But what happens is, in tradition generally it will end up with a local optimum, local minimum. So we cannot able to move forward to the global minimum. So this is one of the major trouble in the traditional optimization methods. So otherwise, generally how we go for minimization method means, we go use gradient descent method. It is nothing but you find a gradient or derivative of a function. From there you see a man which is going in the up or downhill direction. So from here, from first, so we are looking on this genetic algorithm. Sorry for the interruption, I didn't expect this to happen. I'm so sorry for this. uh, Yeah. So we have an objective function, and input to an objective function, you call it as a chromosome, and output we call it as a cost. Generally, what we do is we find the cost. Cost means nothing but we are finding out the fitness of the we are finding out the fitness of the system, how fit the chromosome value is. So that is we are finding out the cost. And generally, if you see, it will look like this. We have a input. We call it as a population, different inputs, and each row we call it as a chromosomes, and chromosomes consist of different genes. So the flow will go like this. We have to create an input initial population, means it's nothing but an array of values. For example, 15 cross 4, 20 cross 5. It is an array of values. I'll show you an example. It's I will understand better. And for each and every member, we will find out what is the Fitness means is if you are going for a minimization problem, you find out the fitness or the cost should be a minimum one. Otherwise, if you are going for a maximization problem, we find out the cost should be a maximum one. So initial first iteration also we find out the fitness, and then what we do, we have to go a set of iterations. Before that, we will find out natural selections. There are different techniques to find out in the parent. Select the parents. From the parents, we will find out the offspring. I'm just skipping all this in order to make the we have to save the time. So suppose I have taken an example. This is nothing but a population. Again, it's a set of values, numbers, which is of an order 8 cross 4. So each and every row we call it as a chromosome, and each and every value we call it as a gene. So here, how many have we? Have eight individual chromosomes, and we have four variables. Suppose if you are using it for an antenna design, these variables, four variables in a row represent any of the antenna parameter. For example, the if you take an array factor, one of the important characteristics in array factor depends upon the amplitude of the antenna elements. So we can have these four variables as the amplitude of the antenna elements. Otherwise, we can have it as a progressive phase from one antenna element to the other. We can have it as a progressive phase. Likewise, we can have variables. Each and every row represent chromosome. Otherwise, an individual solution for a set of problem. Otherwise, we can have it as an integer decimals. Otherwise, we can have it as a bit. So here, just in a MATLAB code, what we can do is previously we generated using a random of n pop comma n variable. If we want it as a bits, just you have to multiply with n bits. For example, if you are 3 bits, you give 3 bits. Nothing but each and every variable will be represented using 3 bits. So totally, you have three bits or four variables. So and that's what we have done is we have find the cost. So before that, we have to select a particular cost function. I'll show you an example how to find a cost function. Generally, for examples, if I have taken a cost function which is xn square, it is nothing but each and every value in the row you have to square it and sum it. That becomes a cost function. So if you from this table, what we have done is each and every value we have squared it and added, and we got this is the cost function. As we have told you, it is a minimization problem. What we can do is we can sort it out. How we sort it out in a ascending order. We can sort the cost value. This is the first time we get the cost value. We sort it out in ascending order, and the corresponding index we have to take, because index we should not miss it. So 6.3 means it is the fourth index. 25 means it is the third index. So this is all about the index. So this is the first time. It is a cost function. This is called sorting. Either we can use a sorting or any other method to find out this. Otherwise, it is called as thresholding. Thresholding means what? We fix a maximum value to it. We find out whatever value which is less than the maximum cost, we can keep it. Other values, if it is greater than the maximum of the cost, we can neglect very easily. So all these techniques are depends upon the individual and their expertise. This we can change it. And once you go for this techniques, after that we have to choose the mate selection. It is nothing but we have to find out the mating pool. As I told you, it is from the biology. It is like you find the parent. Best parents will give the best offspring. For example, we can go with the rounded field selection. If you, for example, if you have strings as your chromosomes, you find the fitness. It is nothing but here is a first x and square. Right? It is already. You find out the equivalent decimal, and it is 13, and you find the square of it. It's just 169, and then and then you and then you find the percentage of the total, which is
which is 169 divided by 1170. That is your percentage of your total. So any of the method, I'm not going deep into any of the method, either it may be a rank selection, holistic method, any of the tournament selection, any of the method you can choose, you can pick it up based on your requirement to find the best parents, and from the best parents we can find out the best offspring. um, so generating offspring, again, you have different methods. You can go with the method called masking. Masking means nothing but you generate a series of bits. All these are nothing to worry about. All these are random numbers. So we cannot say every time it works, but sometimes it works so efficiently. So if it is not working, okay, we can change the mask base and check it out. It is like a trial and error method at the initial stage of our working experience. So masking bits, for example, if you see, I've taken this is the masking bit, and this is the mother bits in the like parent. This is parent pool one, this is parent mother one, mother, and this is your father. So how to create a string bit? Suppose you take first three bits are triple one. So what we can do is, you can, for the if it is all one, you retain the values of the mother. If it is all zeros, you retain the values of the father. Likewise, you can get the half strings from the best mother and best father. So there are different the double checkpoint means first a few digits mother, then father, then mother. That is uniform crossover means this repetition will continue uniformly over the offsprings. And otherwise, you can go with that. Otherwise, you can Whether you always have the rights to choose your beta value. Here it is taken as 0.78. Any value you can take between 0 and 1. Either whether this beta can be a 1 digit, otherwise you can have, if it is a 6 values, you can have 6 digits also. So these are the different crossover methods we can go for that. Then after this mating pool, generation of crossovers, then we can go for mutation. Mutation is nothing but you change the value suddenly. For example, 0 will change to 1, otherwise 1 will be changed to 0. This will give a very good results, and in some cases. So if you see here, if there's decimal numbers 2 and 8, if what we have done is we have interchanged the values of 8 and 2. Otherwise you can interchange 8 values. You can suddenly mutate means change of suddenly change, you change any parameters. And always there is a question, which one we go, whether if from two parents we can do crossovers, otherwise we can suddenly change any parameter. So which is always good is the answer is sometimes not predictable, you cannot say it. It is always a trial. It is always a trial and error. Generally what we can say is crossover is a method where it takes a big jump between two parents. This value will lie between the two parents. It is something like you take a street, and it is a big street, and you are trying to find out something optima within the within that big street. Mutation is nothing but you take little diversion, maybe go to the next nearby street, and you find out what is the optimum value. So always it works out with trial and error methods, and depends upon the applications as well. Then, once your expected output, if you have reached after so many iterations and the time, it is like you have a time constraint. This is time I have to close my program. So all this is done. You can terminate it, and you get the fitness value. For example, one example I would like to show. As I the same thing, I've just I put it in numbers. This is your initial population. So totally, how many in a population is four chromosomes in the population, and the same and if you convert decimal value, it is 13 decimal value. Then you convert find out the x square, and probability is nothing but, for example, 169 divided by 1170 will give the probability, and you find out the expected count is nothing but 0.14 divided by total number of population, which is 4. So multiply by 4, you get the expected count and actual count. Okay, so actual count is nothing but you always round it to nearest one, otherwise two. So this is your first iteration table, and from this is important. Actual count, what you see is first is one, second is two, third is zero, fourth is one. So first population you can have it one time. Second population, this is second value, you can have it two times, and third is not fit value, so you can discard it. And fourth one you can have it one time. So same thing. Same thing. It is here. Whatever I've said, that has been. previous 1 to 1. It has been showed here. Then what we can do is we can do the crossover, means mating. This is a mating pool between 1 and 2. I can do crossover. So point also you have to choose fourth point means 1, 2, 3, 4th point. After fourth point there is a crossover, means interchange between the two parent. 1 0 it becomes 0 and 1, and you take the last two. You see, it's the second bit is your crossover point. There you see 0 1 1 came here, and you have 0 0. So it is called a process between two parent. There is a crossover, and you find out the fitness value. And when you compare the previous table, the fitness value is, you see it is 1170, and now you see the fitness value is 1754. Okay. So the fitness value is increasing. So as like that, we have to go for the iteration. Then after crossover, also you can go with the mutation. It is nothing but the sudden change, and the same thing continues fitness function, and you find out the sum. So as like that, you have to keep on going. Depends upon the iteration, and when you think that you achieve the correct cost function, and that time you can stop. So what's that basic advantages? Little knowledge is enough to be done. Work on with the genetic algorithm. You don't need exact value, but little knowledge that is enough for work with the genetic algorithms. And it works in communication and signal processing. And I would like to show you a MATLAB code. Just a minute, please hold on. I believe the screen is visible and audibility. Can somebody confirm the same?
Yes, yes, ma'am. Thank you.
Thank you. Uh, this is a problem. This is a program which is working on genetic algorithm. So the same thing, whatever example, it is a generic example with which we play with numbers. So here it is an array factor. As you all know, array factors. What do you have? We have arrays of antenna elements of similar antenna elements, which we can arrange in any manner, linear manner or circular manner, elliptical. We can arrange in any manner. This program will show you, and it's a circular array factor. Antenna elements arranged in a circular manner. So if you see here in the first line, it is n equals 1, 4, 6, 8. Means how many rings? We have four rings, four concentric rings. And the first ring contains one element, and second ring contains four elements, third ring contains six, and the fourth ring contains eight elements. So it is a concentric ring which contains similar antenna elements. And the iteration goes to 200, and some theta values are given. I'm not going in detail, but I want to show you how it works. So here, radius. What is the radius of the antenna? Three rings. And mutation rate, natural selection, some random values we have. It has been given. I will just go jump by step through the steps. And this is the actual. This is, as I showed you in the PPT. It is random n pop n variable. I think you have to remember n population. There we have seen n population as 8 and n variable as 4. So here are same thing. You can change always n population comma n variable. So here n variable will be the antenna element. So how many elements we have? 1, 4, 6, 18. Totally 19. So n variable will be 19 here. N pop you can always you can change. I think here it is 200. I think so. So you are creating a population matrix. After that, what we do is we are calling a simple fitness simple fitness function. So simple fitness function is written separately in order to avoid confusion. So here what we give is we will first we will tell code that what is our requirement. Suppose beam width, I want beam width like this, and you write the code for beam angles at decide half power points. I think you know half power points. I think what is the beam angles I just required, and how to compute the array factor. Array factor is nothing but the same formula which we studied in Balanes. This is array factor formula for the circular array. So what is array factor in the left region, and what is the array factor in the right region? It is not. It is nothing but summation of array factors. First ring plus second ring, uh, third ring and fourth ring, summation of array factors. And what's array factor in the main loop reference? So we are just adding into it. Then we find the main loop beam width calculation out. This is basic formula, and this is important. So finding all these things, and finally what we do is we find out something called weight into F2 plus F4 of plus F3. What is F2 plus F2 and F4 is nothing but it will tell you what is the side lobe level. For example, F2 is the left side lobe level, and F4 is the right side lobe level. This program works in the problem of minimizing the side lobe levels. So we want this F2 and F4 should be minimum as possible. For example, if you run an array factor without any minimization, it will show you maybe minus 15 dB or minus 15 dB. So if you want to minimize it, means what? If you minimize the side lobes and you're trying to increase the power radiated in the main board. That is our objective. F2 and F4 has to be minimized. In the same way, beam width has to be minimized. So this I have taken as we have found already F2 plus F4 for F3. So this is so important. So that we have assumed as a cost function. Y equals to weight is some value we can give. Usually depends upon the application. Here between 10 to 18, 10 to 20 you can give any values. 18. So once you run and see, and you will understand what is the weight we have to give. That is their trial and error. So it is the cost function. As I showed in the previous PDF, the cost function is xn square, summation of xn square. And for this case, for this real antenna problem, it is F2 plus F4 plus F3, minimization, all the values. What should, at the end of the result, what we have to get, y have to be a minimum as possible. So this is the cost function. This is the calling of the cost function is done here. Once cost function is done, we go for natural selection. It is the same procedure as I've told in the PDF. Natural selection you have, then you have mutation, you have, then you go iteration by iteration, and every iteration you find the cost. It is a minimization method. You have to find out minimum, whether the cost is minimum or not. This is the plotting. After finding out, you plot it. So I'll just show the result here. This is after running the code, and this is the result you got. So at the angle 0, you got that. This is a normalized to major beam. So it is at 0. You got the maximum radiation, and this is a side lobe. Side lobes, you see, it is much reduced, less than minus 33 dB. So after the use of GA, this is the output optimized array factor radiation pattern we got it. And there is one more you got it. This is a misfitness. So between the iteration and the misfitness, from the first iteration, what is misfitness? It is not fit. Means what? How much the code that the algorithm is fitting into the value? It is not fit. It has to be. It has to come down because it is misfitness. This value has to be as much as possible. As you go on after iteration, at real almost 200 iteration, yeah, this is the output we got it. So we are running it for 200 iteration. If you want to still reduce your side lobe level, you can still increase your iteration. Otherwise, you can randomly change the values of the weight factor, or you can always change the masking, the mutation, any other changes you can see, and that it will help you. So this is your example problem on the genetic algorithm. Um, and Ma'am, how much time I have? I am
Ma'am,
trying to
5 to 8 minutes. 5 to 8 minutes.
5 to 8 minutes. Okay.
Okay,
So
5 to.
at the same time, uh, because I'm talking about ML algorithms, I also want to show how to deal with any other ML algorithms. I'm just because I hope maybe some freshers who are just going to join this. I mean, we going to start working with the um, ML algorithms might be here. So I think this will be helpful for you. What I'm doing is I'm not writing. This is the code GA, which has been written, and after so many errors, this has been done. I'm not doing any writing any code here. I have already taken some codes, which is I have not written. This code I have taken from ChatGPT only. I will tell you how you can actually play with the values, as I told you, how to predict and all, how to predict optimization. Just you give a prompt to the chat gpt, it will give you. I'm just taking one such code, I'll tell you what it is. So this is the right, maybe it will give you a confidence to how to start working with the IML algorithms. I'm using the same code here. So I tell you, this code is talking about training the multiple models. I've used multiple models here. This will predict all the models, and with which it will tell you which is the best model. The code is all I've taken from online only. I have not written anything. I'll tell you how to give inputs. So I'm running the code. This is all function calling, random forest, gradient boosting, extra trees. Okay, this is just for function calling. And before that, I will show you. This is a simple design which is taken from the which is from the paper, which is taken from the paper. Simple pan standard design, which works for certain range of frequency. This is the width of a slot, length of the slot. Usually, this width and length of the slot plays a major role in changing your return losses or bandwidth. So always you can tune it, LA, WA, WB. You can tune any of the parameters. So here, what I'm doing is in the code, I'm tuning LA, LA, WA, and WB, and the same thing has been designed here. And I've used I'm not using any constant, I'm not hard coding it. I've used all variables so that you can use it as a optimetrics. So in the optimetrics, WA, WB, LB, LA, all this been used as optimetrics. Means what? It is the values are changed from 7 to 11 millimeter at the step size of 1.25. You can always change it, and you see the output. And I don't think so. And when you run it, you get a yeah, and you run it, you get different graphs. So this is the input to the ML algorithm. I have imported as a CSV file, and I will, yeah, it is running is over. So this value, whatever I've shown in the HFSS, that file I'm going to give it as a input to it. This is the file, just exported file. I've given the file. Okay. And what it is asking for the input columns. Here, what I'm going to do is I'm going to give the length, width, and one more width to the model, and I'm going to ask what is the frequency of resonance frequency, what is the return loss. I'm going to ask. Previously, what I did, I have given an input where there are a lot of whatever I've taken extracted from the HFS. I've given. Now I train the model. 80% will be used for training and 20% for testing. Now the model is set ready. Okay, now I have to give the input columns. As I told you, input is what? Length, width, width. Okay, these are the inputs. So these are the inputs, and I want the what is the return loss value for it. So this is a name I have used a CSV file. So let me use the same name. Okay. So now the model is started working. It has already gained some knowledge from the given Excel file. Now I'm asking this. This is my input. I am telling the model to work on this return loss. So it is working on the models. All the models, what I mentioned, all the models has been working right now. So all the models has been evaluated, and it is showing a performance comparison table. Okay, it is showing that random forest has the R square value is 0.98. So what is the meaning of R square is it will tell you how exactly, or how there is a fitting between the model and the input data. So it is saying 0.98 in percentage is 98 percentage. So it is giving 98 percentage fitness is there. So when you compare with any other models, it is having it's 0.97, 97. Okay, it is the highest. So random forest is giving the highest fitness with the model and the input data, and other other things should be minimum as possible. So it is said that random forest is good. Okay. Okay, fine. Then what will I ask is I will ask it. Okay, I'll give some data which is not in the Excel file. Some input data, WA, with length, frequency, some data which I have taken, I haven't given names already, input files to it. And I will ask to give the output. What will be return loss for such inputs? I'm asking the model. Now, Now my model will tell that. Okay, these are the values I have given. Random, which is not in the table. Some values. This is the input, and now the model is giving the what this one. Written loss value for the random forest, gradient boosting, all this it is been giving the values. And as it is, it only has told that random forest as the best fitting. So even if you see the values also, random forest has given the good return loss value. When you compare with any other return losses of different models, it has given a good thing. So that is final return loss. It has suggested random forest has given the good thing. Okay, the same way, instead of giving the dimensions, you can give the frequencies and return loss to the model, because I have already modeled it. I have already trained it. Okay, frequency and the return loss you can give, and you ask the model, okay, I've given, so give me the what is the dimensions of the antenna. You can always give the prompt like that. Otherwise, if you're trying to work on the gain or bandwidth or what efficient, whatever it is, first you generate, you do optimetrics, take the data from your any of the simulation tool, give it to the model and train it. After it is trained, then you give any other some other data and get an input from the model. So this is how. So just wanted to show you how this works, even if you do not know coding. So initially start the coding will be difficult point for even for anybody. So right now, if you are starting, so you can start like that. You can ask always, take a code from that, give inputs, train the model. So what you have, you definitely always start with the design of experiment. Some design should be there. You have to generate a values, return loss values, or impedance values, or whatever gain values. You have to train the model. So as much as of data if you are giving, your train will be modeled accurately. It depends upon how many data you are using to train it. So this is what I have yeah it, I wanted to show you in this limited time. I have done with my presentation in the hope in the limit given time. Ma'am.
Ma'am. Yes, ma'am. Thank you very much.
Thank you
Thank
much.
you. Thank you very much.
Sorry, there
Thank
is
you for spending your valuable time. You
okay.
have
Sorry
shared.
from my side. There is a technical glitch. I didn't expect that. Sorry from my side.
Okay, no issue, ma'am. No issue. Dear participants, the test link, FTP reflection, and the feedback form is shared in chat box. You can rejoin at 7:30 p.m. We will have the group photo at 7:30. At 7:30, we will have the group photo. Thank you, ma'am. Thank you very much. If
Thank
you have
thank you.
participants, if you have any queries, you can clarify with ma'am. Participants, if you have any query, clarify with ma'am. Sorry, we will have the group photo at 7:30. Validatory time, we will have the group photo. And we are happy to listen feedback from you related to the FDP. So kindly join at 7:30 to 8 o'clock. Final validatory function. Everyone kindly join. We'll have the group photo at 7:30. Thank you. Thank you for all. Thank you, participants who are ready with the photo session. We will have it. Sorry, we will have it at 7:30 p.m. Sharp 7:30.
Madam,
Our
good
division
evening.
dignitaries will also join. So by that time, you can fill the test.
Madam, good evening,
Okay.
madam. On a clarification, madam.
Yes.
Madam, whether we have to test, appear the test through Google form
One
what you have
minute.
sent or Atal portal.
Sir, feedback, we have to fill it in Atal portal as well as this feedback link.
Okay, ma'am. What about
Journal
testing?
reflection test you have to fill it here only. We will update the mark in Atal portal.
Okay, okay. Fine, madam. Thank you.
Okay. Journal reflection, everyone have to fill. We have to upload this data also in Atal portal. FDP reflection, sorry, FDP reflection. What is the learning outcome? What concept you have learned? How you will implement it in the coming days? So these are the questions which is given by ACT Actual. Once you fill that Google form, we will update it in the Actual portal. Test mark also we will update it in Actual portal. Yes, sir. Yes, without attendance updation, we will update it by Monday. All the attendance, test mark, FDP reflection, we will update it by Monday. So kindly give us 2 days time so that we will update it.
Madam,
Yes, sir.
actually the test is not reflecting in Atal portal, ma'am. I submitted in Google form. Is it okay, ma'am?
What, sir?
I submitted through the link, ma'am. Submitted the test through the link which you have sent, ma'am.
Yeah,
It
yeah,
is not
yes.
available in Atal portal.
In Actual portal, test questions are not available. Here in the feedback, in the link you can share the test. We will update the mark in Actual portal.
Okay. Similarly, other two also, right, ma'am? Feedback and reflections.
Yeah,
Everything.
feedback, you have to submit it in Actual portal.
How
FTP
to get
reflection,
that,
we
ma'am?
will update. How
Okay, ma'am.
to?
How to
You
get that
can go
feedback
into
in the
you can go to your Atal portal,
there's
click
option
this,
called as
there
feedback.
will be our feedback, yes.
Okay, ma'am.
Once we
Okay, ma'am.
update
Thank
the
you.
attendance, and once you have filled the feedback, you will able to download the certificate.